All right, so I wanted to give you an example of constructing a Taylor polynomial, and this is one of the harder ones you ever have to do. And I'll also say that you should try this on your own before you just watch me do it. You'll learn way more from trying something and getting confused than from just watching it. And your brain will tell you that you don't need to try it and get confused. Your brain will tell you that you can just watch it, but what you shouldn't, and that's inertia. But I really think that it would be better for you, like you'll understand this better if you try this and get confused, or even if you get it. But in any one of these, when we're constructing a Taylor polynomial, we need to start taking the derivatives. And by the way, this is going to be centered at 0, which makes it Maclaurin. And Maclaurin is a specific type of Taylor, like a Kleenex is a specific type of tissue, but they're kind of used interchangeably pretty often. But you should know that Taylor is the tissue, Maclaurin is the Kleenex. So when I take the derivative of this, I get, what do I get? Negative 1 minus x to the negative 2. When I take, well, actually, let's find out what f of 0 is. F of 0 is 1. What's f prime of 0? When I plug 1 in there, when I plug 0 in there, I get negative 1. What's the second derivative of x? Well, that's going to be 2 times 1 minus x to negative 3. What's the second derivative at 0? That's going to be 2. What's the third derivative of x? This is going to be negative 6 times 1 minus x to the negative 4. What's the third derivative? It's going to be negative 6. And so then you might get sick of this and say, what's the general term? Now the general term is going to be fn of x. And that's going to be, what does it look like the pattern is here? Well, it's got an n factorial in it. And it also alternates. So I'm going to say that's negative 1 to the n, and then I would check. Negative 1 to the 0 would be positive 1. Negative 1 to the 1 would be negative 1. So the odd numbers are negative, the evens are positive. Looks like I got that right. And then the rest is 1 minus x, I think to the negative n plus 1. Looks like it is. Looks like the case to me. Fn of 0 is going to be negative 1 to the n times n factorial. And now here is where we're constructing the Taylor polynomial. And let's go back to guess my mystery function just because it's fun. Let's say guess my mystery function. If I say g of 0 is 3, g prime of 0 is 8, g double prime of 0 is 24, and g triple prime of 0 is, let's see, 54. What's my approximation going to be? I'll call this Taylor T of x. It's going to be 3 plus 8x plus 24x squared plus 54x cubed. And then if I think about, is that going to be right when I plug in 0 to the derivatives? Well, actually, when I take this first derivative, I'm going to get 2 times 24, which is 48. And I'm going to get 3 times 54. So then if you think of what is t double prime of 0 going to be, it's actually going to be 48. What is t triple prime of 0 going to be? It's actually going to be 3 times 2 times 54. So how do I offset that fact? Well, I have to divide this by 2, and I have to divide this by 3 factorial. Okay, so that is where those factorials come from when we're building our Taylor polynomial. And somebody had asked about that, and that's something that doesn't usually register the first time you do it. It takes several times. And also, I should say that with this type of problem right here, this is like the highest level type AP test stuff you're going to get. So if this makes sense to you on the first run through, you're probably in pretty good shape, I would say, for the AP test. But let's see, this is going to be 1 minus x plus 2x over 2 factorial. I don't want you to think that you're in good shape for the AP test and then just not even try or just not care. So maybe I don't want to give you that false vote of confidence. I'm just trying to say, if you're feeling discouraged because this is difficult, it's supposed to be difficult. This is supposed to be confusing. But if you notice here, there would be an easier way to express this, which is 1 minus x plus x squared minus x cubed plus dot, 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 or 1 over 1 minus x is equal to the sum, n goes from 1 to infinity, of what would this be? Let's make it n goes from 0 to infinity, of negative 1 to the n times x to the n. Now, what we should do is make another one where we figure out what the interval of convergence of this one is. But I think I'm going to let that settle in before I do that next video.